Hello. Um, in this lesson, we cover linear modeling. So far, we've learned about lines and equation of a line, and this is about application of them to formulate a relationship between two quantities. Let's illustrate this with an example. A taxi charges $5 on entry and then $40 for each hour of ride. So as soon as you get into a taxi, it charges you $5 no matter how far you travel or how long you travel for, and then $40 for each hour of ride. Now, we've been asked to write an equation or a rule to show the amount of fare you pay, and we use the pronumeral f to show the fare for a ride that lasts h hours. So the length of the time your ride lasts is h hours. We want to write an equation that relates the amount of the fare to the length of the ride in hours. B. Use your equation or rule to find how the amount to find the amount of fare for a ride of 3 hours. So we want to use the equation to find the amount of fare for a ride that lasts 3 hours. C. Use the equation or rule to find the length of the ride if the fare was $105. Now the fare we are paying is $105. We want to see how long that trip or that ride has taken. And finally, D, sketch the fare versus the length of ride in hours. All right, the first bit is easy because your fare is equal to, if you've been riding for h hours and each hour is 40, so you times h by 40 to get the fare plus the $5 that you're going to pay regardless. So for example, if you were riding for 5 hours, what you will be paying is 5 times 40, which is 200 plus $5, $205. If you've been riding for 2 hours, it's going to be 2 times 40 plus 5. You're going to pay $85. And from that, we can see that we always timesing the time in hours by 40 and you're adding by 5. Then part B, use the equation or rule to find the amount of fare for a ride of 3 hours. Now h is 3 because the length of the ride is 3 hours. So we are going to substitute 3 for h. So that's going to be 40 times 3 plus 5. That gives us 120, 40 times 3 plus 5, 125. So the fare comes to $125. Part C, use the equation or rule to find the length of the ride if the fare was $105. This time the fare is $105. So the value of F here is 105, and we want to see what is the corresponding length of the ride. How many hours you need to ride, so your fare is $105. So we replace F with 105, and we get 105 equal to 40H plus 5. Now we need to solve this equation to find the value of H. The first step is to get rid of this constant, which is plusing 5. And the opposite of plusing 5 is subtracting 5. That's what we do. But we got to do it to both sides. So take away this constant from both sides. So 40 plus H, 40H plus 5, take away 5. That 5 and minus 5, they cancel. And they cancel, and you end up with 40H on the right hand side. On the left hand side is 105, take away 5, gives you 100. So you got 100 equal to 40H. Now to get to H, because H has been times by 40, you got to do the opposite thing, which means divide by 40. You divide both sides by 40. So 40 times H divided by 40. So that 40 goes away. You end up with H. And 100 divided by 40 is 2.5. So H is equal to 2.5. That means the length of the time you've been riding for is 2.5 hours if you paid a fare of $105. And finally, sketch the fare versus the length of the ride in hours. The length of ride in hours. Now, this is the equation we are going to sketch. This is very similar to y equal to, say, 2x plus b, for example, 2x plus 3 or whatever. So you have y equal to, for example, 3x plus 2, y equal to 6x plus 9, always. And we remember that this now, like instead of y you have f here, and instead of x you have h here. So the number next to x is your gradient. So the gradient of this line is going to be 40. And the other number that you're adding or subtracting is your y-intercept. So where your line is going to cross the y-axis, or in this case the f-axis. So that means that we already know one point of the line. It is the 5 value on the f-axis. So if I have this axis as my f, which is replacing the y value or the y-axis, and this axis, which is the right, replaces the x-axis. Now I know that my y-intercept is 5. My y-intercept is 5. So then I start on 5 on the y-axis. I already got 1 point. I need another point, the second point, to be able to draw my line. But how do I get the second point? That is 40, and that is the gradient. And we know 40 can be written as 40 over 1. Now, in this form, if that's my gradient, that's going to be the rise. The top value is the rise, the bottom value is the run. So that means if you go across by 1, I need to go up by 40. So if I start from any point on the line, that's the only point we know so far, I go across by 1 and up by 40, I should be able to get to a new point. So I do that. I start from this point, which I know belongs to the line, go across by 1, this is 1, and go up by 40, that's 5, then I should reach to 45, that point is 45. So from 5 to 45 gives me 40, that length is 40. That is my rise, that is my run. Run is 1, rise is 40, 1, 40. So I get to my new point. This is my new point. Now I have 2 points of the line. I can connect them and extend them. That will give me the whole line. That is the line that is represented by this equation. And using that, you can find the fade for any length of the ride you are having. For example, if your ride is 2 hours, you can go from 2, reach there, and it will meet somewhere around here, which is 85. Or if it is 1.5 hours, it's going to be around 65. So you can 1.5 go up, and you will see that it gives you around 65 to $65 for a ride of 1.5 hours. So that is what they ask us to complete for this question, and this is an example of modeling. That is all for this lesson. Thank you for your attention.